Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I'm going to be taking a look at Linux compatibility from the standpoint of hardware, distributions, and then a few use cases. Stick around. So, whenever we talk about Linux compatibility or compatibility of any kind, we generally talk about generalizations. Generalizations are just rules of thumb. They're not facts, they're just rules of thumb. So, generally speaking, if something is new, a new laptop, a new desktop, a new graphics card, probably you're going to have to wait until the kernel catches up before it's going to work. That if you're willing to do that, then you probably have no problem with moving forward. It's better to kind of get a little bit older hardware, maybe a year older, or just be willing to wait. Accessories and peripherals designed to work on Mac OS and Windows specifically generally aren't going to work on Linux, and Linus found that out during his foray into Linux with his sound card. So third-party hardware is a gamble for the most part because most of them do not support Linux, and it's usually left up to the kernel developers or to some third-party developer inside of the Linux open source world to come up with something that allows it to work. Finally, laptops you're going to find are going to be your biggest challenge to run on Linux, and that's simply because laptops are designed for power performance, trying to draw as little power as possible. So, yeah, and the specs change on the hardware all the time. There will be sometimes there's cost reductions that occur during the manufacture of a particular product line. Those can alter the specs. This can happen on desktops too, but I'll tell you, laptops are going to be more driven to that because competitive than anyone else. There are generally, in my mind, there's 6 hardware categories that we should look at. First one is video card compatibility. If you're running Wayland, you'll want to check with the Wayland website to see what's compatible with Wayland. But for Xorg, for X11 based systems, you'll want to check the Xorg site. They have a project page, and there's a drivers list that will talk about what's actually supported. That, of course, will go across distributions for the most part, provided the version is the same of the Xorg. So I do see a lot of people recommending AMD because their drivers are open source versus NVIDIA, which are not. But, NVIDIA is not as difficult to install as it once was. Like, for example, on Debian, you just install a package. It takes care of blacklisting out the Lenovo driver, putting the NVIDIA driver in, all after a reboot. So it's not a big deal. It's not painful at all. It's pretty easy, actually. Sound card devices, there are guides at linux-sound.org that'll talk about how to find your particular sound card and see if it'll work. Now, I don't believe they have too much in the way of the sound cards that are on the motherboard list, discrete interfaces that are plugged into either the PCI bus or into the USB. There are some that are Thunderbolt as well. I have tested RME interfaces. RME is a high-end engineering company out of Germany that builds audio interfaces that are general. They have several different models. They have some that are USB. They have some that are based on MADI. They have some that are based, even, believe it or not, on FireWire. So that they still make. I've also tested Focusrite Scarletts. They work fine under Linux. They don't require a driver at all, other than the standard USB one. As far as cameras are concerned, yeah, if you're that again, you're going to have to look at the specifics of the model that you're looking to put on the machine. Generally, however, the Logitech devices, which are not supported by Logitech, they do not support Linux at all. There is wide developer support inside the Linux community for it, and one of the tools is Gphoto that you can find will allow you to manage a Logitech camera. But look at the documentation for it to make sure that it lines up with your specific model of the Logitech camera. They have several. Printer compatibility. Generally speaking, PostScript and HP PCL printers will work the best. The reason for that is PostScript's been an open standard for a long time. HP PCL has also been an open standard for some time. So they're well known. They're always plugged into the Linux drivers, the LPR driver system. So Yeah, I mean, it's not a problem. If you're on some other printer other than those that use those two languages, yeah, who knows, right? That's when you'll run into trouble. Wireless interfaces compatibility that changes like the wind. I mean, there are new device types. The Broadcom comes out with hundreds of them each year. So again, it's price performance. It's trying to cost reduce and all this kind of stuff. Yeah. So whether or not your particular wireless interface is going to work or not, that's on your device. That's coming either with your motherboard or your laptop. Check the wireless LAN resources for Linux. Just do a search for it. Chances are it'll probably have your card. If it doesn't, just assume that it won't work. One of the things that I have found with Wi-Fi is that I had to use a temporary solution for quite some time in order to be able to support a wireless driver on the gaming laptop I had until it finally was supported. Yeah. So speaking of that, gaming laptops best avoided. That's my experience and my opinion. Although I guess if you're a gamer and you really have to have that kind of performance on a laptop, well, you're walking down a road that is going to be fraught with pitfalls. I'm sorry to tell you. Yeah, I mean, I on that gaming laptop that I had updates to the kernel that would blow it out of the water. I mean, literally would prevent it from booting. So yeah, it's just not a good environment to live in. My advice: Dell XPS makes a good system that in some cases you can even buy it with Linux pre-installed. Lambda TensorBook is also a good Linux laptop. Uh, Lenovo ThinkPads are great. You'll need to check them though to make sure that the specific model you're interested will work on Linux, and they will tell you that. Although I can tell you the X1 Carbons work very well, including their extreme models. In fact, they work so well that if there's a BIOS update, Linux recognizes it and will install it for you. System 76, also a good starting point, and there's others in there as well. Those are just ones that I had that came to mind. As far as system requirements are concerned, generally speaking, on most distros, it's going to be dual core minimum, quad core recommended. Again, how many cores you need depends on your use case. What are you using it for? If you have some CPU intensive process that's doing like video encoding, you might need upwards of 16 cores to be able to do it. So you need to look at what you're wanting to do. Memory 1 gig, certainly for a text-based system, no problem. You can get it to work. 4 gig minimum for a desktop environment, although you're probably not going to be able to do a whole lot. So I would recommend 8 gig right now, just because you've got almost 1.2, 1.5 gig in use. And then as soon as you open up a modern browser, it could take the rest of the memory out of that 4 gig pile. Storage, 20 and 40 gig is recommended. However, I would recommend 256 gigabyte an M2 NVMe. Why NVMe and not SATA, a SATA SSD? I don't know how much longer the SATA SSDs are going to be supported. There's definitely a market for SSDs in the SAS, and it probably will be for quite some time. But SATA, I don't know. I just can't imagine that's going to last too much longer. Can't give you an exact figure. I don't know, but I can't. I think long term, the handwriting's on the wall. The SATA standard is dead. I don't. The companies are moving to NVMe. The cost is pretty close. Yeah. Anyway, that's my opinion. And the performance is way different, of course. Displays 1024 by 768 is generally the minimum, although you'll probably see them say something like 720p would be recommended. I would recommend going 1920 by 1080 just because if you're developing and you're doing sysadmin tasks and you need the real estate, it's at a minimum. Now, if you can afford a 4K, great. And be able to see that smaller print. Graphics inbuilt or have a large enough monitor. Graphics inbuilt, yeah, you have to evaluate what you need there. Of course, you have to have something of some kind in order for it to work, some kind of graphics processor in order for it to work today. So you can't get around that. But Whether or not you need a discrete GPU, yeah. So my general rule of thumb here again is if you're doing artificial intelligence, machine learning tasks, if you're streaming video or editing video, doing gaming, or you have graphic intensive, maybe you're doing artwork or commercial, industrial, commercial graphics, yeah, you'll need a discrete GPU. Doing 3D rendering also. Uh, the 5 distributions for beginners, I would recommend Elementary OS, Linux Mint, Pop OS. Here's a surprise: Raspberry Pi Desktop. Why? Why that one? Huge support. It has huge support. Its counterpart, the Raspberry Pi OS, which is used on the Raspberry Pi 4, uh, you have just you have a community of educators, teachers, students that are doing from making projects to learning how to program to doing IoT development to even working on embedded development. So, yeah, I mean, I would recommend that definitely. If you're, I don't know what direction you're going into, and if you just want to experiment with Linux, I can't think of a cheaper way to get started than just go buy a Raspberry Pi and start playing with it. Ubuntu Linux, definitely, I would recommend that for beginners. I know I probably have some people that disagree with me. Yes, we know you don't trust Linux, you don't trust Ubuntu. I understand that. But I still think they're a good beginner's OS. They still have a really good support structure for beginners. Debian Linux for system admins because they wrote the initial book on system development and system administration. Endeavor Linux, I wouldn't hesitate to recommend that. Fedora Linux, again, if you're headed toward the RHEL environment where you're administrating RHEL-based systems in the server side of things, yeah, it's a good place to be. Kali Linux for cybersecurity and Rocky Linux for workstation version. Those are just recommendations that I have. Distributions for developers, Debian, Fedora, Silverblue, and I talked about that in the video for why Silverblue. It's because you can create protected environments that are separate, that are basically walled off from each other. So, yeah, your libraries and your versions will not overlap. Pop OS is a good choice, particularly if you're in a Rust environment. The Rust Up environment for Pop OS is very straightforward and very simple to get going on it. Rocky Linux, the workstation version, and for IoT development, I would either go Buildroot or Yocto. For that would be my recommendation there. For AI and machine learning development, Fedora has a very good ecosystem for AI ML, as you would expect, because you're probably going to be porting that onto a RHEL platform or an Ubuntu platform. G-Linux is a Googleized version of Debian. G-Linux, I believe, ran initially on Ubuntu, and then Google backed off of Ubuntu and went to Debian because they wanted to eliminate an extra step in the development process. So you'll have to look around for it. G-Linux is not the easiest thing to find. I think Google tries to try to keep it a good, well-kept secret. But it is a good one, especially if you're using Google servers or the Google Cloud for your AI ML hosts. Ubuntu Linux, I put this on the list because they have de facto support for AI ML, and that de facto support comes from a turnkey solution from NVIDIA, which is their Jetson SoC, system on a chip. They provide hardware and software, a Jetson SDK, which comes on the board, gives you everything you need for development. But they also have the Jetson Linux, which is actually an Ubuntu hosted machine with all of the NVIDIA AI and machine learning software on top of it, as well as there's also a cloud version of that as well if you want to host it on a cloud. Six Linux for based virtual machine hosts. I put Firecracker on the list. It's an intriguing, high-speed, very lightweight machine monitor that allows you to manage and create micro VMs. Overt, which is the Open Virtual Data Center, probably don't hear a lot about that, but it's an excellent VM manager, and that works best with Gluster FS. Proxmox 7 is based on Debian, and of course they also support Ceph and Gluster FS. And it's not, and again, Overt, Proxmox, and XCP and G all support they support Gluster and Ceph to some degree, and they also offer support for things like iSCSI, NFS, and all those kinds of things as well. So yeah, you can use those as well for your hosting. Oracle VirtualBox is a good Type 2 hypervisor. It runs cross-platform, runs on Linux, Mac OS, and Windows. I have never had good luck with the performance on it. It just drives me crazy how slow it is, so I don't use it anymore. QEMU KVM supports most Linux distributions, particularly it was introduced in the kernels of 2.6.20 and above. So if you have that, and you're in good shape if you want to use it. It is command line based unless you want to install Vert Manager or you want to install GNOME boxes. GNOME boxes, you do not have as much control over the VM as you do with Vert Manager. XCP-NG is based on CentOS 7.5. Long term, that's going away. I mean, CentOS is dead. However, the 7.5 is supported beyond December of 2021. The version that gets axed is 8 and above. So, yeah, that's the one that dies in December. This one has a lease on life. I think it's 2 years further down the road from the time they announced it. So 2023, 2024 timeframe, that will be dropping off the planet. So I'm not sure what XMP is going to do about that, but Zen's not going to go away. So I'm sure they'll port it over to something. They also support Gluster FS and Ceph now as of version 8.2. They did not have support for those two before. So 5 distributions for containers. This would be containers running under Linux. Debian, there's also Container Linux, which is formerly was Core OS. Rancher OS and Red Hat Enterprise Linux and Ubuntu Server. If you're running Kubernetes, you'll want to check your documentation for it to see what host that it supports. These are just things that I use and have used here. So with that, that's all I had for today. I hope you enjoyed this kind of a brief look at some suggestions that I have for specific use cases. And I'd be interested to hear what you do and what your use cases are and what specifically you do in order to host it. Hope to see you all again real soon. If you did like this video, please like and subscribe. Hope to see you again very soon. Bye for now.